Hello everybody, my name is Haldar. I play a role as a technical architect in Cognizant Technology Solution. Today I am going to discuss about a topic of transforming inventory forecasting with production machine language. So this is the topic. So this is all about the predictive demand automatized actions. So it is all about the data, machine learning language and decision this topic complies of. So how we will transform the inventory forecasting with based of the applying machine learning language to predictive model, supply model, and optimize the process, transform the inventory process. This is all about I'm going to discuss the next slides one by one. So there are three components like basic component that machine learning, the data itself on which the machine learning is going to apply, and based on the apply, the output is the decision which leads to the automated execution. Now I'm going to the next slide. So in today's story, what we will tell why inventory forecasting fails. Inventory forecasting means it is required for all organization and all big companies where they need to keep inventory in different warehouse for different purpose. They use that inventory like for a catering, they use the inventory in the kitchen. For nail polish operating system, they use the chemicals stored in the as a inventory in the warehouse and then use it to make that particular nail polish kind of thing and different kind of confectionery. So this all things is needed. So inventory forecasting plays a major role in different industry. So what today I'm going to discuss and so how we can optimize the inventory forecasting using machine learning language. So the second point I'm going to discuss about the reference architecture, how data driven decision has been taken by using machine learning language, then the production machine learning life cycle, the business impact and key takeaway from the optimization process. Okay. In today's date, inventory planning faces a volatile environment of the demand uncertainty. There are different kind of barrier in the supply chain process which may cause the supply chain process disruption. As a result, the manual spreadsheet driven process we have to apply, and this also lead to the delay the decision leading to stock out and excess inventory and operational risk. This volatile demand and supply disruption, manual planning delays, and different kind of lack of pay. So this is happening due to lack of predictive intelligence, no foresight to adjust the changes. This gap we are trying to implement here. So in this topic, we will discuss about the how we can implement the predictive intelligence to optimize the inventory planning. The next one is why forecasting fails. As I told, different kind of barriers, different kind of errors, and different kind of approval process, different kind of rules regulation, different kind of audit. There are thousands number of reason why the forecast got failed. For an example, like there is statics rules, there is siloed data, there is no feedback loop, there is lots of these. I only mentioned three. As I told, there is thousands of barrier and thousands of blockage which cause the forecast fail. So using the machine learning intelligence and intelligence decision, we are going to try to overcome those barriers to make the forecast accurate and perfect and optimize the inventory process. In the next slide, I am trying to describe the target architecture, how we will build the target architecture of the system, how it will mitigate the traditional inventory management to make it more effective and less time consuming, and it became the optimized in nature of in terms of cost, in terms of labor, in terms of automation, in terms of every time it will get optimized. So there are this is that basic architecture of the system like data, feature, model and decisions. So the data came from the unified data pipeline. We will harmonize the data and make the data source as a unified data pipelines. Then the It comes as a signal, high value predictive signals. Then the model, Azure native ML model apply on top of that. Then we are taking the automated action flow based on the result we get by applying the machine learning language, machine learning algorithm to those model on top of the data, and then generate the decision based on the output. In the next slide, I provided the data ingestion layer. How the data ingestion layer occur? If you see in that, a different kind of normalization, harmonization data is there. ERP, POS, IoT, these are the data sources which ingest the data in inventory process. The inventory process in the warehouse, there is different kind of warehouse. There is inbound warehouse, there might be outbound warehouse. There are different kind of warehouse. So in those warehouse, all the data has been collected from different kind of system. All the warehouse do not have the same kind of system. Like one warehouse might have ERP system, another warehouse might have IoT system. So the data lake, that all the data come ingest inside that and come to the data lake, which build on top of the Azure platform. Azure Data Factory pipeline comes all the data lake Gen 2 storage. We store all the data, harmonize the data. If you see the data quality and governance, this is all the data quality, which is the data cleansing process. Like you verifying the email ID, you are cleaning the address space, you are cleaning the other catalog objects, this kind of thing, validation, data quality validation, data cleansing take its process. Also data governance also take its process, library schema validation, lineage and catalog, which I was telling earlier, and then provide the secure access control to the secure person, to the specified person who having assigned the role to access the data. The next one is the feature engineering, which sessionalize the signal and optimize the disk. Optimize the disk for given the failure and the inventory management short and lack of data, lack of inventory to the warehouse. It reduce the risk of that. Also, it reduce the maximum over capacity and over targeted material has been ordered overly, that it also reduce the risk for that. So this is all about that particular description of that particular feature engineering, which is a major part of the processes. So in this slide, I described all the detailed feature of the feature engineering, which defines to lag feature, differentiational signal. So this kind of things, this is I'm providing an example. So like lag feature, session signal, then enrich feature will provide it promotion and weather signal. This is a kind of a example I have provided here. So this incorporate promotion and the kind of thing, and then we are getting the accurate result. My intention is to provide all the detail by using an example. How what is this feature engineering and why we will use feature engineering. In the next slide, I try to describe the model validation comprised of different kind of steps, along which is a backtesting, evaluate accuracy metrics by using different kind of procedure like MAE, MAC, mean, standard evaluation, then MSM, APE. These are the different kind of statistic method that used to evaluate accurate metrics for the back testing and different kind of other testing also. Identify bias and fairness. There is different kind of, as I told blockage, different kind of restriction, different kind of approval process and other rules that block those inventory, then disturb the supply chain process to get that inventory into the warehouse in proper time. So each identify all the biases and try to identify and collect those information to push to the next step. Okay, so it has different kind of the object like EDA, fairness indicator. These are the different kind of metrics, deriving techniques, all the other metrics are there. So that use to collect the barriers and try to push into the next layer so that we can identify the and remove them, and then we are trying to address those bias and all those stoppage blockage to avoid the supply chain disruption. I'm going to the next slide, which is talking about the deployment and the MLOps, which is the CI/CD for MLOps using the machine learning. There is track and managing models, register and version ML models. These are the deployment of the processes which involve in the machine learning implementation for the inventory management optimization. After applying the machine learning algorithm like linear regression to a particular model based on the input data, then what we need to do? We need to maintain the metadata for auditing, register the version ML for deployment, then ML model for the deployment, then monitor performances. These all the things talking about model registry and monitoring alerts, talking about the deployment process, deployment in the MLOps. Now, the prediction to action, how we are predicting this. This comes in picture when we harmonize the data, normalize the data and apply machine learning algorithm to them. This is a learning phase. This is a model generation phase. This is a deployment development. Once the model is trained properly, then we will do the model registry and it passes to the actual data. So we are maintaining the data using the historical data with the supervised learning. Then after if the model is automated and tuned properly, then actual data is provided as a out input to that particular model after deployment and module registry, and then it will generate automatic data, output data and predicted data from the model application after deployment to get the proper inventory what need to be ordered. Suppose we need 30, so the predict will define that okay we need 28 or 29. This is very close to the expected order. It will never order 10, which might lead to a less inventories that might disrupt the business process, or some overheld inventory like 70, that also waste of the inventory that will occur. So that way it will be supposed to order very close to the target like 30, 20, 29. So that's how actually after train it will generate the actual data. So that's how after taking the data it will order the inventory from the third party vendor or the suppliers. That is how the inventory process occurs. That is the business impact for that. If you order proper amount of inventory and kept in the warehouse, it will reduce stockouts, lower inventory cost, faster decision, it will improve efficiency, and it will continue help to continue the business process, which subsequently led to the revenue, net revenue of the company, of the organization. Like this, I provide a healthcare scenario here for an example, where demand forecasting for supplier capacity planning, they do capacity planning and proactive replenishment. So do that how they improve efficiency. And in the capacity planning, if you see, there are sub steps where they used to implement, prepare for the high demand, then allocate resource efficiently. Then for in the proactive replenishment, what they do, they maintain the adequate inventory and reduce risk shortage. These all the steps they applied the one by one. There is a data layer. After the data layer harmonization of the data preparation layer, they applied to the next step the data where the applied the email algorithms applied to get the actual output by learning those model one by one to get accuracy. And finally the model is registered to a deployment environment where it connect to the application and produced proper output. Supply chain scenario, where again I am providing another scenario where logistic optimization done, disruption prediction, risk aware planning has been done. The main basic objective is to show you how different kind of optimization applied in different business case and different industry and different domain. Here in the logistic optimization, they adapt this adapt route in advance. This is a kind of business scenario. So in the sub scenario, they applied some machine learning algorithm and generate some data by after deploying those models, and this data flows to the next step like optimize shipping cost. These are one sub step is dependent on another, and it will lead to a different optimization, subsequently short processes, finally it leads to a total optimized way material optimization to say target optimization. So it improve resilience. If you see in that risk aware planning, this is another main process where the optimization has been acquired using machine learning applied in that model for the inventory optimization. That what we can say in here, like this kind of optimization using machine learning and supervised learning, we can minimize the risk of waste of the inventory, as well as we can also ensure that our business will learn in proper way and proper time. It will not stop due to the lack of the inventory. in our system. It will also optimize the supply chain process. It will remove all the disruption from the main processes, sub processes, and different kind of approval processes. Rule, it will take care of the rule automatically. Where manual intervention is not required, that's how you can be very sure that okay, your business is running very successfully using this optimization, where it will finally lead to the revenue for the organization. So this is all about my topic over here: inventory management optimization using machine learning language. Thank you.